Hello, everyone. I'm Alex Strachan, Professor of Materials Engineering at Purdue and co-director of nanoHUB and chipshub. And I'd like to tell you briefly some of the latest developments on the site that we're very proud of. If you know anything about nanoHUB, you probably know that we have lots of simulation tools to model devices and materials. These are available online, and most of them are available as apps so that a non-expert can click a couple of buttons and run a simulation and explore the results. So they're widely used in education. Over the last decade or so, we added infrastructure and tools for machine learning, AI, and data to make data findable, accessible, interoperable, and reusable. This really enables the development of autonomous labs, self-driving labs. Over the last year, we've extended our offerings in the area of EDA. These are tools that are used to design chips. Can be even is what you need to tape out or make a chip. So really, nanoHUB now can cover the range from materials all the way to the level of the chip, enabling the digital twins where you can combine experimental data, physics-based simulations, and AI. So let me give you an example of our recent work in these. Two of these tools, OpenLane and OpenRoad, were used by a program during the summer of 2024 here at Purdue called STARS, where we introduced 60 students to EDA, to chips design. This is important because once the tool is available on nanoHUB, we can enable it throughout the country. And these tools are not easy to install, so many institutions don't have the expertise or the computational power to offer this type of software. Just to give you an idea, installing and getting these tools ready take anywhere between 1 and 4 months of a software engineer. And we work very closely with Purdue's Rosen Center for Advanced Computing, and the simulations actually were run through nanoHUB on a supercomputer called Anvil, supported by the National Science Foundation. So we're very happy and very proud of this partnership. Just to give you an idea, this is a picture of the STARS and READY students. 60 of those were the ones that were performing EDA simulations on nanoHUB. Just to give you an idea of the complexity of the computational resources needed, we served almost 2,000 sessions over this 5-week program, and we provided 6,000 interactive hours, so where students are playing with the tool and learning the tool, and a total of 200 CPU hours over the 5 weeks. It's interesting to see that during the first weeks, there's more interactive simulations where every student is running, they're learning about the software, but they're running very small simulations. The CPU hour demand is not high. Towards the end, students work in groups. There are fewer sessions, but each session is much more intensive computationally. We are part of important workforce development at the national level, SCALE and SCALE K-12, which focus on K-12, pre-college, and college education. MEST works on working professionals. All of these are supported by the Department of Defense. We also have partnerships with the Purdue Applied Research Institute and the Silicon Crossroads ME Commons. And all of these efforts, including a partnership with Pasadena City College and MintKern, all of these efforts are helping us develop the infrastructure, provide the tools, and provide the educational material to enable microelectronics and semiconductor education. So through nanoHUB, all of these efforts share educational content. They share hands-on educational activities that use simulations, as we saw earlier. They can also advertise research opportunities, internships, and whatnot. And nanoHUB also provides interesting research analytics to each of these, because we know who runs the simulation, how many resources are shared. These numbers that you see here, these 4 plots on the bottom right, are from Scale. This is a national program, and you can see it's a partner of universities, and they have deployed 200 resources. They've been used thousands of times, and you can see that Scale is growing into becoming a national program where course and simulation presence in almost every state in the country. Finally, nanoHUB is not only about computer simulations, but also experimental data. We've been working with the Berg Nanotechnology Center here at Purdue, and we developed what we call dashboards for them, where the engineers can upload their data and monitor pieces of equipment over time. And so you can see that you can look at different dashboards. Here's a metrology dashboard, and you can go in and look at individual pieces of equipment over time and see how they're operating. This is the first critical step to develop digital twins. And we're working with our colleagues at Berg to take this data, add AI to it, add physics-based simulations, and turn and develop digital twins for both equipment and devices or materials. So let me finish with a few opportunities and thinking towards the future. So nanoHUB, we're very proud of the reach that we have. We have active users on 800 plus universities at some point during our 2 decades of existence. And this is important because when you compare our reach with the type of access that, for example, EDA vendors have, these are 2 examples of very leading EDA software vendors. They have licenses in about 200 universities. So everyone else, most of them being community colleges, R3 universities, currently don't have access to these tools. nanoHUB can actually provide access to them through our web interface. If you look on the right, these are institutions ranked by the number of users, simulation users on nanoHUB. And we're very proud of this list, where you see, of course, Purdue is the top, but you see that we have simulation users, thousands of users running simulations on nanoHUB in Arizona State, UIUC, Northwestern, and Florida Agricultural and Mechanical University. That's a minority-serving institution. And then we have Harvard and Stanford and Ball State in Muncie, Indiana, UTEP, another minority-serving institution, Chicago State University, and HBCU. So we are serving both the high research R1 institutions, but also and equally non-research intensive and minority serving institutions. So there's really an opportunity to scale our efforts in education for semiconductors, for materials, for devices across the nation. So that's on the educational side. On the research side, we're very excited about the infrastructure that we're developing that combines AI, physics-based simulation, and data. And you can think that once you can put all of these pieces together, you can have an optimization, accelerate innovation by coming up with new experiments to run. The data feeds automatically into the system. The machine learning models get better. And through sequential information acquisition process, you can improve devices, you can improve chips, you can improve processes in a way that was not possible before. So these are recent developments. We're very excited about the possibilities and look forward to interacting and collaborating with groups around the country and the world. Thank you very much.